Okay, so I put up this States of Matter. It's a PDF, and you can just kind of make your way through the slides. It's a good overview of solid, liquid, gas, aqueous. Now, we know that the states of matter are solid, liquid, gas, and plasma. We're going to add aqueous because aqueous is a solid dissolved in water or a solution, which is going to be really important to us when we start doing double replacement reactions, which we're getting to. We're going to do types of reactions next. So do you see the little S in parentheses? That's an L in parentheses, a G, and an AQ. What they want you to do with these is that when you're writing your own reactions, when you're writing your own chemical reactions, after each of the compounds or elements in your chemical reaction, you have to put something in parentheses, either solid, liquid, gas, or aqueous. So I'm going to show you how to figure out which is which. Now, if you look at the equation I have here, this is combustion. We're going to talk about that later too. Methane is CH4, and it is always a gas. That's just one that you know, probably going to be told in the problem. O2 is a Broncliffe. These are our Broncliffes, right? Bromine, oxygen, hydrogen, nitrogen, chlorine, iodine, and fluorine. These guys are always gases. Now, this is our exception. Bromine can be a liquid. If you look on the periodic table, there are two elemental elements, meaning in their elemental form, that are liquid. They're different colors. They are bromine and mercury. Those are the only two that are liquids, okay, in their elemental form. Now, bromine's the exception. We just say, for simplicity's sake, that all of our Broncliffes are gases, but technically bromine's a liquid. Now, here's the thing with bromine. This is what happens. When bromine's in its elemental state, bromine is a Broncliffe, which means it's Br2. It's not just Br. If it's Br, it's liquid. If it's Br2, it's probably going to evaporate into a gas. The liquid is very volatile. It stays a liquid for a certain amount of time, but it kind of goes back and forth between that liquid and solid phase. So it's like one of those ones that's a little, you know, there's an exception to everything in chemistry. That's it here, okay? So for our purposes, Broncliffes are all gases, okay? But you have to remember that Br, when it's by itself, not that it is, because when in its molecular form or its elemental form, it's always Br2, but you have to remember that it's a different color on the periodic table because it's technically a liquid, and mercury is also a liquid. All of the black things on the periodic table, so like zinc, calcium, carbon, they're all black on the periodic table, which means they're solids. So they would get an S next to them. So like if you had Zn in your equation, it would say S because it's just by itself. If you look at a periodic table, you'll notice there are different colors. These ones are usually a different color from regular. Most of the elements on the periodic table are solids, so most of them are black. Then you have your gases. So you have your oxygen, your fluorine, your iodine, your the ones on that side of the periodic table. A lot of them are gases. Just have to look at a periodic table to know. But again, back to this. If you have a Broncliffe, this is what's going to come up a lot. If you have a Broncliffe, any of these, we're going to call it a gas, okay? So up here, O2, Broncliffe, it's a gas, okay? As we go further on in this little thing on the computer here, you're going to learn that carbon dioxide is also a gas. It's just something you have to know. Water, unless you're told differently, is a liquid. Water obviously could be a gas. It could be a solid, right? Because we have ice, we have steam. But unless you're told that it's steam, unless you're told that it's ice, just go with liquid, okay? So, wait, go back here, sorry. Okay, so, sorry, I'm having some technical issues here. Okay, so, again, we have solids, anything that's elemental. Most elements in their regular states are solids. Your exceptions are bromine and mercury, and all of your gases, which are on the right side of your periodic table. Generally your negative elements. Things like oxygen, again, like oxygen, fluorine, chlorine, those things are all gases. So then you have aqueous. The definition of aqueous is a solid that's dissolved in water. Okay, so it's a solution. We talked before about solute and solvent. Water is the solvent. Whatever's dissolved in it is the solute. Remember, the lute is in the vent. So you'll notice down here that they have NaCl as a solid, and they're probably told that, or you're being told that. H2O plus H2O, sorry. That what they're saying is they're dissolving NaCl in water versus just saying NaCl aqueous. They're the same things, only this is an easier way to show it. Do you see that? So instead of writing NaCl solid plus H2O, you write NaCl aqueous. It just means that the NaCl is dissolved in the water. That's where you get that, okay? All right. Moving on. So how do you predict states of matter? That's the next question. These are some of your gases at room temperature: hydrogen, nitrogen, oxygen, fluorine, chlorine. Oh yeah, I'm sorry. I meant to say hydrogen too. Remember, hydrogen is one of our Bronscliffs. So it is the exception. It's on the other side of the periodic table, but it's still a gas. Fluorine, chlorine, ammonia is always a gas, unless you're told otherwise. Carbon monoxide and carbon dioxide are gases. Nitrogen monoxide and nitrogen dioxide are gases. Sulfur dioxide and sulfur trioxide. A lot of those covalent compounds like that, especially ones that contain carbon, nitrogen, and sulfur, and either like oxygen or chlorine, iodine, one of those things, they're almost always gases. Again, we're probably not going to get that far in, so I wouldn't worry too much about that. Just know these ones that are given to you on this. Hydrogen compounds, hydrogen chloride, hydrogen cyanide, usually are gases, with the exception of anything that's an acid. Acids are considered aqueous, so just be careful with that. Again, here we go. I just said acids are always aqueous, so things that begin with hydrogen. So phosphoric acid, sulfuric acid, hydrochloric acid, which contradicts what it says up here, by the way, but don't worry about that. Just make your acids aqueous. It's not going to make that much difference to you. Mr. Fyock will show the rest of you in AP Chem why it works both ways. Any phrases that refer to being dissolved or in solution means the compound is aqueous. If something says this is dissolved or this is in solution, like NaCl in solution is NaCl AQ, okay? Liquids are bromine, mercury, and water. We already talked about that. All other elements are solid. When in doubt, so are most other compounds, particularly ionic compounds, are usually solids, unless you're told differently. This one, the only thing I want to point out here is that your diatomics are usually gas. We're going to assume that our diatomics are gas. I want to go through a couple of examples with you. Sulfur is being said or being put in as a solid because it's by itself, so it's in its elemental form. It is black on the periodic table, so it's a solid. H2 is Bronscliff, so it's a gas. H2S is one of those ones that I just, is a hydrogen compound that is not necessarily an acid, so it is a gas too. Again, don't worry too much about that. I'm not going to ask you those. Cu is solid because it's by itself. Sulfur is solid because it's by itself. So CuS together is a solid. I'll show you later with the solubility table how you figure out whether a compound is solid or aqueous. O2 is a Bronscliff. H2 is a Bronscliff, both gases. H2O, unless you're told differently, is a liquid. KClO3, they're telling you it's a solid. KCl is a solid because it's an ionic compound, so you just assume unless you know otherwise. O2 is Bronscliff, so it's a gas. So these are single replacement reactions, which we're going to get into a little bit later. I will talk to you about the activity series, about who gets to knock who out. I'm going to do that in a video in the future. Well, actually, it's here somewhere with this one, but it's going to be a video in the future. Close that out, sorry. They're showing you that KI down here. So they're saying you that Ki is aqueous. You're probably told that in the problem. Cl2 is a gas because it's Broncliffe. KCl is aqueous. Here, we probably used a solubility chart to figure that out. I'll show you how to do that later. And I2 is a Broncliffe. So what you really need to remember from these things, watch out, are these kinds of things, what I'm showing you here. This is the quiz that I put up. I want you to tell me whether you think these are solid, liquid, gas, or aqueous. O2, Broncliffe, gives you a hint. NaCl, it's probably an ionic compound. H3PO4, that's an acid. So what do we say about acids? Si, what do we say about elements by themselves? Hg, what do we say about Hg? What do we know about that? H2O, what do we know about water? HCl, well, it's probably an acid. Could it be a hydrogen compound? Yeah, but I'd go with the acid. I2 is a Broncliffe, Br2 is a Broncliffe. Again, be careful with that one. CO is one of those ones that they talked about as being an exception. Not an exception, as being a gas, sorry. And CaNO3, see what you can do with that one. So that gives you a pretty good overview on what a solid, liquid, and a gas are. And you should start using, can you zoom in up here? You should start using your solid, liquid, gas, aqueous when you're writing your reactions. So everything should be either solid, liquid, gas, or aqueous. Again, a lot of your problems, it's going to say right in the word problem. Aqueous, sodium chloride, whatever it is, adds to oxygen. You should know that oxygen's O2 because it's a Broncliffe. And you get this and that. It'll tell you. So you have to be careful with that because NaCl normally you would assume is an ionic compound, so it's a solid. So again, give these a shot. I'll put the answers up later. This is an assignment, so I'm going to put it in as an assignment. So I want you to try this, see how you do. It's going to be either complete or incomplete, so don't worry too much about how you do. I'll give you some feedback and let you know how you did. Ask me questions, send me questions again via Remind anytime you want. Thanks.